Kaohsiung City in southern Taiwan has natural harbors and wide hinterlands. It has recently become the most developing industrial seaport and commercial metropolis in Taiwan. If industrial and domestic sewage from high economic growth and heavy population in the city is not properly treated, the living quality and environment will be worsened. Therefore, the functions of city sewer system and sewage treatment plants become quite important. The sewer system in Kaohsiung City uses stormwater and sewage separation system. Rainwater is collected by stormwater sewer system and directly drains to rivers and the sea. Domestic and industrial sewage is collected underground sewage sewer system, processed in sewage treatment plants, and drains in surface water. In this way, cityscape environmental hygiene can be improved, as well as living quality. Based on Kaohsiung City Sewage Sewer System Plan, there are 10 sewage districts from the north to the south. Each district has its own sewage collection system and treatment plant. Till year 2013, there are 4 operating plants: Qijun Central District Sewage Treatment Plant, Nanju Sewage Treatment Plant, Fengshan River Sewage Treatment Plant, and Dashun Sewage Treatment Plant. 2 plants are being built: Qimei and Linhai Sewage Treatment Plants. The sewage district in Kaohsiung City accounts for 76% of the all. It is separated into east and west collection systems. West system collects city central sewage into Changong Roadman Pipe. East system collects suburb sewage and leads to Kaishan Roadman Pipe. The east and west systems meet in the convergence station in Chenzhen Triangle Park. Then it passes Kuojian Roadman Pipe, crosses Kaohsiung Port District, and flows to the Central District Sewage Treatment Plant. As meeting the standards, it drains to the sea. Within the transitional period of household connection installation, domestic, industrial, and upstream sewage is collected to sewage treatment plant by intersection method. It is a high priority to improve river pollution, and household connection is actively proceeded to increase sewer installation rate at the same time. Central District Sewage Treatment Plant is located in Chongzhou Dashantou Seaside Qijun District. The plant measures 900 by 140 meters, which is 12.6 hectares. Based on Kaohsiung City Sewage Sewer System Plan, it started to be built in 1979 and was completed in 1986. It officially started to operate on 24th January 1987. The design daily processing capacity is 750,000 CMD, and the average daily processing capacity is about 55 to 65 CMD at present. It will be expanded to 1 million CMD in final period. Primary treatment is adopted to be sewage treatment method, and effluent drains to the sea from outlet pipe. Now let us introduce the sewage treatment process in Central District Sewage Treatment Plant. The whole process separates into 2 parts: sewage and sludge. First, sewage is collected in Kaohsiung City and flows into distribution pumping station in the Central District Sewage Treatment Plant through Cross Harbor Main Pipe. The pumping station is located in 30 meters underground. There are 5 large pump sets in each north and south sides. Sewage is pumped to groundwater tank. Then through 2,100 meter caliber procedural pipes in north and south sides, it is led to pre-treatment station by gravity. This is the deepest embedded sewage pumping station with the largest flow capacity in Taiwan. The daily sewage processing capacity is up to 1,260,000 CMD. The pre-treatment station uses 2 mechanical screening facilities, which are stationary screen and bar filter screen. This is also the first adoption of double screening method in Taiwan. Stationary screen can remove large trash, such as wood, coconut shell, etc. Bar filter screen can block floating or soft trash, such as plastic bags, leaves, etc. Then sewage is led to grid aeration separation tank. There are 7 aeration blowers here. They stir air into sewage to separate grit. Then settled grit is separated by grit scraper at the bottom and disposed. This is also the first funnel-type scraping grit aeration separation tank in Taiwan. After that, sewage is led to primary settling tank by gravity. Sewage from pre-treatment goes into another stage in primary settling tank. The whole primary settling tank has 30 water tanks. Every one is 12 by 50 meters rectangle shapes. They are symmetrically and closely laid out to reduce tank area. They are with lids on in order to reduce air pollution. Sewage flow speed slows down here. Here, some invisible suspended particulates settle down by settlement principle. 30% BOD and 30 to 40% SS can be removed from sewage in this stage. After the separated sludge from settlement is collected by scraper, it is ground by grinding machine in sludge control room. Then it is conveyed to sludge thickener by sludge pressurizing pump. The separated supernatant liquid gathers in overflow tank. Via procedural pipe, it is led to disinfection pool with gravity method and disinfected for drainage. The non-OCR in the tank is made from seawater and disinfection. By using the intake facility in electrolysis station, seawater is first grid settled, pressurized with water pump, and sent to 6 sets of electrolyzer facilities to produce non-OCR and hydrogen, in which hydrogen is released to atmosphere by cyclone separator. Non-OCR is mixed with supernatant liquid for disinfection. The channels in disinfection pool are designed a roundabout way to increase contact time and achieve effective disinfection. This is the first use of electrolyzer seawater in Taiwan to produce non-OCR for disinfection, which reduces the risk of using chlorine. The daily sewage processing capacity of the whole plant is detected by a rectangular weir flow meter in the outlet of disinfection pool. The treated water is called effluent. It is led to drainage pumping station by gravity. After the pressurization of 5 drainage pump sets and regulation of surge tank, it drains and diffuses to the sea from outlet pipe. This surge tank, like a traditional chimney, is 40 meters in height. Its main function is to let excess water flow inside to regulate the pressure of outlet pipe. When the pressure of outlet pipe is too high, it can increase diffusion effect. Outlet pipe is a steel tube buried beneath seabed. Its inner diameter of the front 2,400 meters is 1.8 meters. The inner diameter of late 600 meters gradually narrows down to 1.6, 1.4, and 1.2 meters. Porous diffusion tube's inner diameter is 200 meters. Its outlet end is located in about 22 meters under sea level. The entire pipeline has cathodic protection in order to extend its lifespan. Near the outlet pipes, 5 permanent warning buoys are also set up to level and warn the surrounding water areas. Some effluent is recycled for the usage of the plant, such as washing, gland sealing, and defoaming. Next part is sludge. The suspended particulates settled in primary settling tank are called sludge. It is collected by scraper and pumped into thickener. Then it is compacted and concentrated at the bottom of tank with gravity sedimentation method. It makes the water content decrease from 98% to under 95%. The concentrated sludge is sent to be dewatered. Its purpose is to separate solid and liquid to become sludge cakes and separated liquid. Separated liquid is collected and sent back to sewage treatment system. The water content of the water sludge cakes decreases to under 75%. There are central sludge holding tank, a screw conveyor at the bottom, and periodically transported by truck to the incineration plant for burning. The noteworthy part is the dewatering machines, which use belt filtering method in the plant. Through up and low filter belts, roller plates to dewater. In order to increase dewatering efficiency, polymer is added to the sludge for adjustment. This is the main process of sludge. Overall, this large sewage treatment plant with complex processes needs a control hub, which is a central monitoring system (PMC). The monitoring procedures include automatic control loop, processing operation, signal transmission, alarm handling, automatic monitoring analysis equipment and safety measures, etc. Through Man-Machine Interface (MMI), real-time information can always be obtained, and the operational status of whole plant facility is monitored. In order to achieve overall control, this plant has dual-loop power supply systems and emergency generators to ensure operation without blackouts. Because of increasing difficulty of water resources development, it is important to actively recycle water resources. This plant uses membrane bioreactor (MBR) and reverse osmosis systems (RO) to recycle and reuse water resources. The function of membrane bioreactor is to use the membranes immersed in biological pool to filtrate activated sludge and solids from biological treatment and recycle clean water. The larger particulates can continuously react and degrade in the pool. Through membrane separation technology, bioreactor function can be enhanced maximally. The advantages of membrane bioreactor include via membrane filtration, good and stable quality of outlet water with high volume load, short hydraulic retention time, small footprint, and capable replacement of conventional sewage treatment plant settling tank and filtration unit. The suspended solids and turbidity of processed sewage are close to zero, and most pathogenic bacteria can be removed. Compared to general reverse osmosis, the separation effect is far superior to the conventional settling tank, sand filtration, and other treatments. It is suitable for the transformation of all sewage treatment plant, which only needs MBR membrane facility installment. When membrane bioreactor operates in the conditions of high volume low, low sludge low, and low sludge age, domestic sewage can basically achieve no remain sludge drainage. Disinfectant additive is reduced, and safe reusing water is acquired. Membrane bioreactor treatment system is a new generation technology of water recycling. In the world trend of global warming, energy saving, emission reduction, and environment sustainable development as the premise. This plan starts off renewable energy resources and green city vision. Using adequate sunlight and open terrain characteristics in children area, photovoltaic system is set up on the existing building roofs in plant area. With the concept of energy saving and environmentally friendly, it can achieve green power efficiency. The capacity of photovoltaic system in the Central District Sewage Treatment Plant is about 58 kW. The electricity saving is equal to about New Taiwan dollars 140,000 annually. The system is set up on the roof of existing pumping station building, and the generated electricity is delivered and used within the plant area. Its characteristics are: 1. Monitoring system is set up in the plant. The personnel can check generating capacity through computer at any time. 2. It provides clean and non-carbon electricity to the North Drainage pumping station and reduce electricity costs. 3. The system can be used as a regional energy educational demonstration to promote solar power and deeply embed the concepts of resource conservation and sustainable development. Water is the precious resource of the earth. Through sewer treatment, We look forward to establishing a sound water circulation system to make us and future generations be able to enjoy clean water resource. We shall work together to improve our living environmental hygiene and create a comfortable modern living space.